Have you ever faced a situation where one database operation succeeds, but another fails, leaving your data in an inconsistent state? That's exactly why Spring Boot provides the @transactional annotation. Let's understand it in a simple way. Imagine you're transferring money from account A to account B. First, 1,000 rupees is deducted from account A. Then, 1,000 rupees is added to account B. But what if the application crashes after deduction and before addition? The money disappears. To prevent such problems, both operations should either complete successfully together or fail together. This concept is called a transaction. In Spring Boot, we use @transactional to manage transactions automatically. @service, public class bank service. @transactional, public void transfer money. Debit account, credit account. When this method starts, Spring opens a transaction. If every operation succeeds, Spring commits the transaction. If an exception occurs, Spring rolls back all changes. As a result, the database remains consistent. Now let's understand the async properties of a transaction. A. Atomicity. Either all operations succeed or none succeed. C. Consistency. The database remains in a valid state before and after the transaction. I. Isolation. Multiple transactions should not interfere with each other. D. Durability. Once data is committed, it remains saved even after a system crash. Now let's discuss rollback behavior. By default, Spring rolls back transactions only for unchecked exceptions, such as runtime exception. Example: @transactional, public void, save user, .save data. Throw new runtime exception, error. The transaction will be rolled back. But if a checked exception occurs, Spring does not roll back by default. To handle that, use @transactional rollback for equals exception class. This tells Spring to roll back even for checked exceptions. Now let's talk about transaction propagation. Propagation defines what should happen when one transactional method calls another transactional method. The most commonly used option is @transactional propagation equals propagation required. Required means join the existing transaction if one already exists. Otherwise, create a new transaction. Another useful option is propagation requires new. This always creates a completely new transaction. Now let's discuss isolation levels. Isolation levels help manage concurrent transactions. Spring supports read uncommitted, read committed, repeatable read, serializable. Example: @transactional, isolation equals isolation read committed. The default isolation level usually depends on the database being used. One important interview question: will @transactional work on private methods? The answer is no. Spring uses proxies to manage transactions, and proxy-based transactions work only on public methods. Another common mistake is calling a transactional method from another method inside the same class. In that case, the transaction may not be applied because the call bypasses the Spring proxy. So always be careful with self-invocation. Let's summarize. @transactional manages database transactions automatically. It ensures data consistency. Successful execution leads to commit. Exceptions can trigger rollback. Propagation controls transaction behavior. Isolation controls concurrent access. Works best on public methods managed by Spring. If you're building enterprise applications with Spring Boot, understanding @transactional is absolutely essential, because reliable transaction management is the foundation of every robust application. Thanks for watching. And don't forget to like, share, and subscribe for more Spring Boot tutorials.